Now, I believe it was Nathan on Friday. We had all of those rectangles drawn under our curve. And Nathan said, can we just draw in those little triangles and then we'd be more accurate? Yes, we would. And by drawing in those little triangles, we're really drawing trapezoids. What is a trapezoid? Thank you.
Quadrilateral.
Okay, a quadrilateral where two sides are parallel. The other two necessarily aren't. Okay. So this is an isosceles trapezoid with a base and arms and legs. But two sides are parallel. The other two aren't. Okay. So here's the real question. If I gave you a trapezoid, how would you find the area?
It's 1/2 base times height.
You have to find the two triangles on each side.
But you also have to measure
I
how long.
like to split it up. I like to split it up into a rectangle and two triangles.
How long are
Let's
his
do an
arms
over
and legs?
approximation.
What's his shoe size?
Times the area of his legs and arms.
Yeah.
Yeah, okay.
This is how we find the area of a trapezoid. 1/2 times the height times the sum of the bases. Okay? And when I say bases, we're talking about the parallel sides. Okay? And height would be the distance between those two bases. Okay? So, if I ask you to approximate the area using trapezoids, okay, the process is going to be very similar to what we did on Friday. Okay, we still have to figure out how many trapezoids we're going to use. It's probably going to be given to you. And just like on Friday, the more the better. And the more accurate. Okay? Determine the height of each trapezoid. That's going to be our delta x. B minus A over N. That's determining the height of each trapezoid. Now in our rectangles, that was the width. Okay, but in the trapezoids, it's the height because it's going to be the distance between our two bases. Okay. Our bases will be determined by the function value, similar to the height of our rectangles on Friday. Okay. Then we're going to have to find the area of each of those trapezoids and add them together.
Is that an N or an H?
That is an N. Thank you. Well, delta x is our height, but we still find it by b minus a over n. Okay, same way we found it's still our delta x.
So delta x is h.
Yes. So yeah, our trapezoids are going to look like this. Where this is each of the heights, and then here are our bases. Does that help?
Can't you just make it one big trapezoid?
Well,
You could, but
no. The way I drew these, it looks like they're fitting under a line, and then yes, you could. But if it's a curve, it's not.
So these are going to be darn. There's probably
A lot of right angle triangles.
It's going to depend on the curve. Okay, so let's go to your foldable. Does this look familiar? Yes, we found this 3 times. But now we're going to do a different area approximation, okay? So first of all, when you open your flap, okay, let's go ahead and find delta x. Okay, so let's refresh ourselves. B minus A over N, and I want 4 trapezoids. So our delta x is 1/2. Okay, so that's referring to the height of each of our trapezoids. Okay, so what's happening is we're going to have a trapezoid here.
It is a triangle.
Closer.
a trapezoid here. Trapezoid here. And trapezoid here.
And it's still
rectangular because we
Why would you even use rectangles if this is more accurate?
Well, the rectangles are going to help us when we actually go to find the actual.
Oh, maybe, sir.
If each distance goes to where it touches the line.
Yes. So each of those bases, we're going to find by the function value, right? Because it's going to be the point on the curve. Okay? So we have to find the area of 4 trapezoids. So remember, our area is 1/2 times the height times, oops, that's me, times the sum of our bases. Okay? So what I'm going to do is I'm going to show you what it's going to look like for 4 separate areas, and then there is going to be a way to consolidate this for kind of a shortcut. Okay? So first trapezoid, 1/2 times the height times, well, our first base is 0, plus, what is this base right here? This is when x is 1/2, so how long is that base?
1/4.
1/4.
How do you know the height was?
So the heights are our function values. So at 0, we're at
okay.
0.
So,
At 1/2, we're at 1/4.
okay, I'm thinking of
Okay? Plus 1/2 times the height times the sum of our bases. So this second, this base is 1/4 plus, what is this base here when x is 1?
1.
1.
Why does it work out from
Our function is, here, it's 1/2 times the height. Our height is 1/2 because that's the distance between each of these trapezoids.
So it's gonna be the same.
Like sideways trapezoid.
Oh, from the formula.
Yes. Okay?
So then inside the parentheses, it's just gonna be the same chain thing. So it's gonna be 1 plus.
Okay? You're going to see a pattern here. So our next trapezoid, what is the first base? 1. And what's our second base here when x is 3/2?
9 fours. 9 fours. 9 fours.
Okay? And then our last trapezoid is 1/2 times the height times the sum of our bases. So our first base,
9 fours.
9 fours, plus our second base,
4.
4. And remember, we got all of those numbers by our function values, right?
So that looks a lot more accurate.
Okay. Now, what do you notice?
1 8.
Okay. So all of these are being multiplied by 1/4 essentially. Okay, I'm going to keep it as 1/2 times 1/2. Okay, so we're going to kind of do the same thing. We're going to factor those out, right? Then we have 0 plus, we have 2 1/4,
2 1s,
2 1s,
9 plus 1.
2 9/4, and 1 4. Okay, so basically all of our inner bases get counted twice. Okay,
Wait,
So-
one more time how to find the bases. Like base 1 is.
so like here between 1 and 3/2, our first base was 1 squared, which is 1, and our second base was 3/2 squared, which is 9/4. So we're just plugging it into our equation. Okay. Okay, so instead of having to write 4 different area trapezoid formulas, we can just write it like this. Okay? 1/2 times the height times the sum of our bases, where our inner bases get counted twice.
Some of all.
The sum of all the bases, yes. Okay? So, Yeah, the inner ones get counted twice, the outer ones, okay, they only get counted once.
11/4.
Okay, so yeah, we have 4 trapezoids, but we had a total of 5 bases.
Is that a pattern every time?
Yes.
So-
Okay, so when you had your rectangles, if you had 4 rectangles, you had 4 numbers, you had 4 heights. Here with our trapezoids, if we have 4 trapezoids, we have to have 5 bases. If we have 6 trapezoids, we'd have 7 bases. Okay?
Wait, is that the answer I love for?
No, she just wanted to.
Okay.
We add-
Well, this would be 0 plus 1/2 plus 2 plus 9/2 plus 4, which ends up being 11.
I just, cause I decided just like did it without like the first way.
Uh-huh.
And I got 45/16.
It's 44/16.
Have you-
It comes out to 44/16. And then you
Is that?
simplify it down to 11/4.
Oh, I must just.
Yeah, you must have added one little thing wrong. Because you should have 1/16 plus,
5/16.
Oh, I got 2/16. That's 1/4 times 1/4, that'd be 1/8.
That's 1/16.
that's 1/16. It's okay. All right, so our area is 11/4, okay? Which is closer than any of our left and right approximations. Okay,
But not exactly.
they're not
Are
exact.
we ever gonna do like this kind of stuff?
Yeah, that's what we're gonna do, Friday. Okay, now, so let's talk about our trapezoid, area. Okay, you're gonna see some formulas, and I'm gonna write my formula a little bit differently, because I want you to think about the area of a trapezoid. Okay, so when you go to find the area using the trapezoid formula, I want you to think of 1/2 times the height.
Just delta X.
Yes.
Go.
Where h is delta x, times the sum of our bases. Okay, and remember, our first base is going to be by itself, but then we're going to have to double our inner bases. And then our last base would be by itself. Okay. Okay. And how do you find the bases? Okay, so any of our bases are just going to be the function value. Okay. Okay. Now for practice, we're going to do an easy example. Why is this an easy example, and what's special about it?
Linear.
Linear. There's gonna be a slight area under X.
Okay, so we're going to actually find the exact area with this, because our trapezoids are going to fit perfectly under a line.
Can we use one big trapezoid at this? Yeah.
Okay, we could, but just to practice using our formula, I would like to use the 4 trapezoids. Okay?
Okay, man.
Thank you for the suggestion, though.
Just thinking that'd be the
I like it. But, okay, this is what's happening. We have 4 trapezoids fitting very nicely under our curve. Okay, so first thing we need to calculate is delta x and we calculate delta x by,
6 times 2 divided by 4, which is 1.
oh man, that was very nice. Okay. So our area is 1/2 times our height, which is 1, times, okay, our first base. So, what?
I was just thinking, since our height is 1, do we really need to even plug it into the equation because anything times 1 is?
You wouldn't need to plug it in. Okay. So this is what's going to happen, right? We're going to evaluate our function at 2, right? And that's going to be the height of the first base, plus 2 times the function at 3, plus 2 times the function at 4, plus 2 times the function at 5, and then just the function at 6. So that will give us all of our different bases. Okay, the function value gives us our bases. So what are we working with here? We have 1/2 times 1. Okay, I'm not going to write it. F of 2.
9.
Plus 2 times f of 3.
Oh.
Plus 2 times,
15.
plus 2 times,
18.
plus. So those are our bases. Now, I wrote this stuff in here. You would not need to. Some of you are going to go just straight to writing this, and that is fine. Okay? Some of you are just going to be working on your calculator, figuring out these function values. That's fine. What is our exact area?
Exact.
Excellent.
Did those times like cancel out the 2 that are multiplied to the function?
Yes, but then this would be 9/2 and 21/2. But if you want to have an easier way to add them all up, that would be fine. Okay. All right. Let's get a little bit more intense.
Oh,
Okay, so we are approximating the area from here to here
With 6 traps?
with 6 trapezoids. Yeah. Okay, this is just terrible.
That's actually really accurate. Like, I like how the lines don't even touch the bottom.
Yeah, it's pretty special. Okay. Delta x.
1/6.
2 minus 1 over 6. 1/6. So that is our trapezoid height. Okay. So then, to find the area, 1/2 times the height times, we want our first base plus 2 of our next base. Oh, not 2. What is our next base? What number are we going to plug in? What? 7/6, because that's our delta x. Right? We have to add a 6. Okay. 2 times f of 8/6. 2 times f of 9/6. Plus 2 times f of 10/6. How do I know when to stop using 2's? Okay, and our last one is the end of our interval, f of 2. Okay. So, let's start working on these values. I would use your math fraction button to help you, so you don't have to approximate all those decimals and then have a rounding error at the end.
What's an abstraction though?
You just math. It's just-
I don't know about your calculator, but you're gonna get decimals for these. Then push math, fraction, enter, and it'll turn it to a fraction for you. You didn't know that? Oh my goodness. Welcome to a whole new world.
I was just leaving them in the fraction. I don't know.
Yes, that is another good suggestion that you may not remember from last year or whenever. If you type in something, you can press second enter and it'll bring it back up and you can just change the X value. You don't have to retype it.
I have a question.
Mm-hmm.
So as I'm moving into this, I find myself like one off, I guess.
So here was it. We had 2, 86,
Yeah.
5, 9, 13, 4, 34, 9. I think you're doing well.
And
So now you need
then
11,
like
6.
run out, because I have a 6 strings of 6
So-
records.
So now you're gonna have 7 of those numbers. Because we're talking about 7 different times. Yeah. You're always gonna have one more number than you do fraction. So you are always one off. Okay, you're working on these numbers for me. Okay, so how about this? Just to make our lives a little bit easier, if you haven't started working on it yet, there's 7 numbers. Okay, so pod 1 you have f of 1 and f of 7, 6. Pod 2 you have f of 8, 6 and 9, 6. Pod 4 you have 10, 6. Pod 5, 11, 6 and 2. Pod 1, what is f of 1?
2.
And 7, 6.
85, 36.
Okay. Pod 3, f of 8, 6. That's you. What did I say?
3.
Pod 2.
25 nines,
And 9, 6.
13.
10, 6.
34 nines.
11, 6.
And 2,
157 over 36.
Okay. So our area, you can either give it to me as 721 over 216, or you can approximate it to 3.338. Okay. But this is more accurate than using rectangles.
Yeah.
It's also not as fun.
Maybe you'll not find that.
Now, okay, so first of all, you know that there's eventually going to be a way where we can find the exact area. So some of you may think Okay. Is data always given to us in a nice equation? No. Data doesn't always fit y equals x squared, right? So sometimes we are given data and maybe a table. Okay? And this is really when these methods are going to be beneficial for us, is when we have tabular data. Okay? So let's talk about how we would use these methods to find area under a curve when we have tabular data.
Well,
Statistics people, are your eyes hurting? The table.
tabular data is just.
All right. So, first of all, what I want you to notice is that what is our change in x in our table?
1/2.
1/2. So notice how it is consistent. That is important. Okay, all of these shortcuts that we are using go out the window if delta x is not consistent. Okay, if delta x is not consistent, you're going to have to go back to finding each individual area. Okay, now, what?
Never mind. Could you just find one that's, like if it went from like 0 to 3/4, 1 to whatever, could you just go by
If
the
you
ones?
if you could find consistency, that would be fine. But if this went 1/2, 1, 1.7, 2.1, blah blah blah, then you have to do everything individually. Okay? But that's not the case here. We do have consistency. Now, I'm asking us to use each method with 3 rectangles or trapezoids. Okay? So how do we figure out delta x if I have this data? How did you do that?
B minus A over N.
B minus A over N. Okay? So we're going to have one rectangle from 0 to 1, one rectangle from 1 to 2, and one rectangle from 2 to 3. Okay? Let's first start with our left-hand approximations. The area, what is the width of each of these? 1 times the left hand is going to give us the height. So what is the okay, so our first rectangle has height what? 2, because that is the left height. Our second rectangle has height 6, because that is the left height. And our third rectangle has height 4. So this area is
12.
Let's talk about right hand. We still have the same 3 subintervals here. Our delta x is still 1, but now we're going to do right hand. So what is our first rectangle's height?
2.
Our second rectangle? And our third?
5. Dude.
Okay, yes. Now we want to do the midpoint. Okay, so our area, we still have width of 1. What's the height of the first rectangle? 4. What about the second rectangle? 7. And the third? Right? last but not least, trapezoids. So first of all, 1/2
Good one.
times 1 times our bases. Our first base, 2 plus 2 times
12.
6 plus 2 times 4 plus just 5 because that's our last base.
Be about 3,000.
Seven would be 13.
Mm-hmm. Yeah.
That's not what I got.
That's not what I got.
Oh gosh, what am I doing? I wrote the 13.5 over 27. Okay. So what I have for you is a worksheet. Yay! Okay, now I will warn you. So Mr. Kriegel and I, we share copies. And he said, "Hey, do you want me to make these copies?" And I said, "No, I want to make my own trapezoidal worksheet because I don't like the formula on here." And he made them for me anyway because he forgot, but I didn't want to waste paper. So I don't like the trapezoid formula, how it's written. It's the same thing that we do. I just don't like how it's written.
So can you
So-
write the new one on the board?
What?
Are you gonna write the new one on the board?
It's the one we got.
Well, you wrote it in your notes, didn't you?
Oh, yeah.
Oh, yeah.
So basically what's happening here is it has b minus a over 2n, which is the same thing as 1/2 times the height is how I want you to think of it. Okay, so it's the same thing. I just like 1/2 times height. Okay, but whatever. You didn't listen to me, so.
It's great.
He didn't listen fast enough. I'm just kidding.